Good morning, students. New chapter, chapter 6, Electromagnetic Induction. Yes, in 12th, we have discussed about electrostatics, chapter number 1 and 2, that is behavior of stationary charges. Chapter number 3, current. When charges are in motion, they form current. Chapter number 4, what is effect of moving charges? Means current produces magnetic field. Moving charges produces magnetic field. Moving charges produces magnetic field. In 5th chapter, we have discussed about magnetism and magnetic materials. Now, we know that there are two branches different, electricity and magnetism. Initially, electricity and magnetism, they were considered separate and unrelated. Okay, before electricity and magnetism were considered separate and unrelated. But after some numbers of experiments performed by Einstein, Ampere, Faraday, Henry, they proved that yes, these two branches, that is electricity and magnetism, they are not separate, they are not unrelated, but they are related. Now, how related? Yes, in chapter number 4 we have proved. Okay, moving charges, that is current. Moving charges, that is current, generates magnetic field. Yes or no? Yes, it is. We know that moving charges, that is current, produces magnetic field. So yes, you may ask a question, is reverse possible? Okay. Is change in magnetic field produces current, or magnetic field causes the charges in motion? Yes, it is possible. Is reverse of this phenomenon possible? Then yes, your answer is yes, it is possible. Due to change in magnetic fields. Here I have a star symbol because conditions apply. That we will see in next lecture. Okay, due to change in magnetic field, current is generated. Clear about this? So yes, its reverse is possible. Due to change in magnetic field, current is generated. So simple. See, here it is. Moving charges, that is current, produces magnetic field, and reverse, that is magnetic field, produces electric current. So obviously they are not separate, they are not unrelated, they are as related to each other. Clear? And that's why electricity and magnetism, they are no different concept, no phenomena. Okay, it is called electromagnetic. Why this word electromagnetic is used? Because they are not separate. Okay, their common branch is called electromagnetism. Clear about this? Okay, so yes, we have to remember this introduction. Okay, now after numbers of experiments performed by Faraday and Henry, they proved that changes in magnetic field, due to changes in magnetic field, current is generated in the the coil or in the object, and it is called electromagnetic induction. Okay, after numbers of experiments, they prove that due to change in magnetic field, due to change in magnetic field, start why magnetic field? Okay, due to change in magnetic field, current is generated in coil. Current is generated in coil, and this phenomenon, okay, this phenomenon is called electromagnetic induction. It is called electromagnetic induction. It is called electromagnetic induction. So what is electromagnetic induction? Due to changes in magnetic field, current is generated in coil. This phenomenon is called electromagnetic induction. It is called electromagnetic induction. Clear about this? Okay. Now, which experiments prove this statement? So Faraday performed numbers of experiments. And conclusion of that experiment is this statement. Okay. Now we will see 3 experiments performed by Faraday. Okay. Faraday's experiment. First experiment, that is experiment number 1. What is first experiment? See, a bar magnet, North Pole, South Pole, a coil, and this coil is connected with galvanometer. Why galvanometer? Because galvanometer measures current. Flowing from this coil. Now see, what is experiment number 1? If this magnet having north pole facing this coil is moved in this direction, then this galvanometer shows some deflection. And if this galvanometer shows some deflection, means there is current flowing from galvanometer, current flowing from this coil. Clear about this? Okay, so yes, what is first experiment? Okay, he took one coil which is connected with galvanometer, a bar magnet. When a bar magnet facing north pole is moved towards coil, this galvanometer, suppose it is a scale of galvanometer, this galvanometer is 0, this galvanometer shows some deflection. For example. Clear about this? Okay, so yes, galvanometer shows some deflection. It means current is flowing from this coil. So due to motion of this magnet towards this coil, current is produced in this coil. Clear about this? Okay. If I move this magnet away from coil, then what happens? Again, this galvanometer shows some indication. Some deflection, means current is flowing in this coil. But that galvanometer now shows deflection in opposite direction. Indicating current is produced in opposite direction. Clear about this? So yes, if coil is moving towards magnet, current is produced in one direction in coil. Suppose magnet is moving in opposite direction, then current is also induced in opposite direction. Clear about this? Because this galvanometer shows deflection in opposite direction. Okay. Now, when this magnet is moved faster, then yes, value of current measured by galvanometer is large. Value of current measured by galvanometer is large. When you move this magnet faster, okay, then this galvanometer shows large current. Clear about this? So yes, these are some experiments performed by Faraday. Experiment number 1. Yes, we have moved magnet, but if we take this magnet stationary and if we move this coil towards and away, then the same results are obtained. Clear about this? Yes, if magnet is moving or if coil is moving, current is produced in this coil. So we can say, due to relative motion between magnet and coil, due to relative motion between coil and magnet, okay, due to relative motion between coil and magnet, current is generated in coil. Clear about this? So yes, this first experiment performed by Faraday. One magnet, one coil. Coil is connected with galvanometer. When magnet is moved towards or away, this galvanometer shows deflection into opposite directions. Okay, indicating presence of current in this coil. Now, what is experiment number 2? Experiment number 2 is, if it is a coil, galvanometer is connected with it, okay, and if the bar magnet is replaced by a coil which is connected with battery. Now this bar magnet is replaced by a coil which is connected with battery. It is connected with battery means from this coil current is flowing, and we know that this current carrying loop behaves as magnet. Yes, this current carrying loop produces magnetic field. Yes or no? Yes, it is. Yes or no? Yes, it is. Okay. So yes, again experiments are repeated. Okay, if this coil having battery is moved towards or away, the galvanometer connected in second coil shows some deflection, indicating presence of current in this coil. Similar results. Just this magnet is replaced by this current carrying coil. Clear about this? So yes, if this coil is moved towards that galvanometer, if it shows deflection in this direction, if this coil is moved away, then this galvanometer shows deflection in opposite direction. So yes, due to motion of coil in two different directions, direction of current also reverses. Direction of current induced also reverses. So again, same result. Okay, due to relative motion between two coils, due to relative motion between two coils, coils. Current is generated in coil. Current is generated in coil. So yes, after these two experiments, you may say that yes, if there is relative motion, there is magnetic field produced. No, it is not necessary. Okay, to generate current, relative motion only is not way. Then why current is generated? We will see experiment number 3. See, what is experiment number 3? Now experiment number 3. See, if again I have two coils. One coil is connected with galvanometer. Another coil is connected with a battery. Another coil is connected with a battery and a key. That is key. Okay, and yes, these two coils are stationary. Okay, so yes, experiment 3 performed by Faraday. Two coil. One coil is connected with galvanometer. Another coil is connected with battery and a key. Yes, these two coils are stationary. They are stationary. There is no relative motion. Between them. Then what happened? See, when he switched on key, when key is closed, then at the time when he closed the key, this galvanometer at time or for small time, for a very very small time, galvanometer shows deflection. Clear? So yes, when this key is closed, okay, this galvanometer shows deflection for very very small time. Clear about this? Then when key is closed, it does not indicate, okay, it did not indicate any deflection. Okay, galvanometer shows no deflection. Okay, when after key is closed, no deflection of galvanometer. And next, at moment when key is open, okay, at moment when key is open, here when key is closed, then for a small time galvanometer shows deflection. At moment when key is open for a small time, again galvanometer shows deflection, but in opposite direction. It means what? Okay, whenever we on switch, okay, then if galvanometer shows deflection in this direction, when we off the switch, galvanometer shows deflection in this direction. But during on-off time, during moment when we switch on and switch off the key. Okay, so yes, at these two times, galvanometer shows deflection for very very small time. So yes, if two coils are stationary, no relative motion between them, then also current is induced in this coil. Okay, for a small time, current is induced in is induced in coil. So yes, we have discussed 3 experiments, experiment 1, experiment 2 and experiment 3. Okay, first 2 experiments, there is relative motion, and due to that relative motion we can say current is produced. In third case there is no relative motion but still current is produced. So what is actual reason? What is actual reason that current is produced? What is actual reason that current is produced? Okay, that we will see next. In this lecture we have discussed about 3 experiments performed by Faraday. In these 3 lectures we have discussed about 3 experiments performed by Faraday. Okay, now in next lecture we will discuss about magnetic flux and what is actual reason for producing such current. So yes students, it is chapter number 6, electromagnetic induction. It is all about introduction. Experiments performed by Faraday. Yes, these are only experiments and their results. Now what is actual reason? We do not know what is actual reason that current is produced in this coil. Okay, so now in next lecture we will see actual reason why current is induced in coil. Okay.